Hello, I Anand Jain from Hanumangarh, Rajasthan welcomes you to Shridevi Classes YouTube channel where we inculcate interest and confidence in science and engineering subject. Today in our class 12th senior secondary physics playlist in our chapter electromagnetism we will continue applications of Biot Savart Law, and in this second learning video we will explain some of the important questions of our senior secondary board exam and engineering and medical entrance exam. So let's start application of Biot Savart Law. Today we will start application of Biot Savart Law with this example where we have to find out resultant magnetic field flux density or magnetic induction at the center point of equilateral triangle of side A and carrying I current forming a closed enclosure around this observation point. Now in these current configuration where current form a closed enclosure around observation point, the magnetic field contribution of all individual current get added up being in the same direction, and due to symmetry of this configuration we can say the magnetic field of one current carrying side when multiplied by 3 will give the total magnetic field of all three sides. We know as per Biot Savart Law the magnetic field of BC current length of finite length at this center position, the total magnetic contribution is given by this formula where I is current in this conductor side and R is this minimum perpendicular distance of observation position center of this triangle from conductor, and these two angles are limiting angle from two conductor side along current element and position vector, and for an equilateral triangle the center and one vertex connection line bisect triangle angle, and equilateral triangle angle is 60 and when it is bisected the two angle become 30 each. So magnetic contribution of BC length is given by mu 0 I upon 4 pi r cos 30 plus cos 30. Now the value of cos 30 is root 3 by 2 and the 2 addition will make it root 3, and if we substitute this perpendicular length of observation position from current length this r, then we can find out magnetic field by this relation. Now this complete AO dash length is A cos 30. It is projection of this A length at 30-degree line, and A to O dash, this point is O dash, length is A cos 30, and the center of triangle divide this perpendicular bisector in 2:1 ratio. So O to O dash length is, or the perpendicular minimum distance is 1/3 of total AO dash distance, and AO distance is A cos 30. Cos 30 is root 3 by 2, and when it is made 1/3, the perpendicular distance of O from BC length become A divided by 2 root 3. One can remember this A divided by 2 root 3 figure as this triangle got three sides equal of length A, then the center and one vertex got length A by root 3, and this perpendicular minimum distance of observation point from conductor side is half of this center to vertex length and is half of A by root 3 or A divided by 2 root 3. Magnetic field of one side BC of this equilateral triangle carrying current I at this perpendicular r distance is given by this relation, and particular r distance is A by 2 root 3. And if we see the direction of magnetic field using Maxwell right hand thumb rule, when conductor is gripped in right hand with thumb pointing the direction of current, then this tip of curled finger at observation position indicate perpendicular to this plane outward denoted by this dot direction of individual magnetic field contribution, and since three sides are symmetrical and all three produce magnetic field in the same direction of the same magnitude, then the total magnetic field will become 3 times of magnetic field contribution of one conductor side, and one conductor side contribute this magnetic field with perpendicular distance A by 2 root 3. So in place of R, when we place A by 2 root 3, and this magnitude is when made 3 times, this root 3 with this root 3 multiplied becomes 3, 3 multiplied by 3 become 9, and this 2 will cancel this 4 and make it 2, and our resultant magnetic field will become 9 by 2 mu 0 I pi a, where I is current in equilateral triangle and A is one side of equilateral triangle. If the periphery of this equilateral triangle is S, then S is 3a, and when we substitute the periphery S in place of one conductor side, the resultant magnetic field of current carrying equilateral triangle will become 27 by 2 mu 0 I upon pi s, where I is current in equilateral triangle and S is periphery length of wire used to make equilateral triangle. In the plane of this equilateral triangle at the center position, the current flowing in three sides of equilateral triangle form an enclosure, and for such enclosed current distribution, the magnetic contribution of individual currents will add together as indicated by the tip of curled right hand finger when thumb of right hand is indicating respective current, and this magnetic field at symmetrical center position is normal to this current loop plane outward as indicated by this dot. The magnetic field of such closed loop current configuration at symmetrical center position, which is straight and normal to plane, is obtained by another format of right hand rule. When we are finding out magnetic field of a straight conductor, the straight thumb was along current of conductor and curled finger has represented the circular magnetic field surrounding straight conductor. But when current form a curved enclosure and magnetic field at symmetrical center position is straight, then we can interchange assignment of curled finger and thumb, and for such curved current distribution, curved finger indicate the direction of current in the loop, and this thumb normal to this plane indicate straight magnetic field acting at the symmetrical center position of such current distribution. In this next example, we have to find out resultant magnetic induction at this symmetrical center O position from a square current carrying coil of side A and current I, and current is in anti-clockwise direction as shown here. So once again, this symmetrical current distribution around this central position form a closed enclosure, and their magnetic contribution will add together here and become a straight magnetic field at this symmetrical center position normal to this current loop, and the direction of that magnetic field can be obtained by modified form of Maxwell right hand rule, as these four straight current of square sides form a closed curvature. So the curl of finger of right hand, if is along the current directions as shown here in anti-clockwise direction, then this straight thumb of right hand perpendicular to this plane indicate outward magnetic field towards us. If in place of this anti-clockwise current distribution, if this current distribution is in clockwise direction, then the resultant magnetic field will become once again normal to this square plane, but for clockwise current it would be inwards denoted by crosshair, but this anti-clockwise current enclosure will form a magnetic field towards us as denoted by a dot here. Now due to symmetry, we can find out magnetic field contribution of one straight side at this center position, and the resultant magnetic field of these four sides will become 4 times of magnetic field of one current side. So for finite AB length, magnetic field is given as mu 0 I upon 4 pi perpendicular distance, and perpendicular distance of observation point from current length is half of square side A by 2, and square form angle 90 degree at one corner and center will bisect that angle. So limiting angle by symmetry become 45 degree each, and cosine of 45 is 1 by root 2. And when we add the 2, this become 2 by root 2 or root 2, and this 2 with that root 2 become 2 root 2, and the remaining figure is mu 0 I upon 4 pi A, and this is magnetic field of one side AB, and all four sides will contribute symmetrical magnetic field in the same direction. So the resultant will become 4 times of this single value, and when we simplify, this 4 in numerator and denominator get cancel out, and resultant magnetic field will become 2 root 2 mu 0 I upon pi A. And if this periphery of square A 4A is S, then in terms of periphery S, the resultant magnetic field will become 8 root 2 mu 0 I upon pi S, and this clearly indicate that for the same periphery and same current, a symmetrical enclosure equilateral triangle has produced more magnetic field than the square. So higher the sides of regular polygon, lower will be the resultant magnetic field at center position with same periphery length of conductor and same amount of current. This conventional textbook problem will enhance our subject clarity about superposition of two magnetic field contribution from infinite long straight conductors. We have given two infinite and mutually perpendicular conductor carrying identical I current, and these perpendicular current intersect at origin of our xy plane. So one current is along x direction and second current is along y direction as shown in this diagram, and we have to find out resultant magnetic field at 4 points. One is P at 3, 4 coordinate in first quadrature. Second is Q with minus 3, 4 coordinates in second quadrature. The third is minus 3, minus 4 R point in third quadrature. And the last is 3, minus 4 S position in fourth quadrature. For this observation position P, these two current, I in positive X direction and this I in positive Y direction, won't form a closed enclosure. So definitely their magnetic contribution for this position are in opposite direction, and we can prove this from right hand thumb rule too. When this X axis current carrying conductor is gripped in right hand with thumb pointing the direction of current, this tip of curled finger at this position indicate outward magnetic field as denoted by brown dot here. Whereas for this Y direction current, when conductor is gripped in right hand, thumb pointing the plus Y direction of current, then this curled finger tip at this observation position shows inward magnetic field by this cross diagram from Y current. So magnetic field of X axis current is dot upward and magnetic field of Y axis current is cross downward. For this P point, coordinate 3, 4 respectively represent. This 3 is X ordinate, distance from Y axis, whereas 4 is abscissa, distance from X axis as this distance. And for infinite long conductor carry I current and 4 unit distance, magnetic field contribution is mu 0 I upon 2 pi 4. 4 is the distance of observation point from straight infinite long conductor, and this magnetic field is vertically upward denoted by dot. And for Y direction current, the perpendicular distance is 3 unit, so its magnetic contribution is mu 0 I upon 2 pi, perpendicular distance 3, and it is cross inward. This inward magnetic field being closer condition of current from observation position is bigger in magnitude. So from bigger magnitude, this smaller magnitude is subtracted, and LCM 12 and 4 minus 3 will become 1, and our resultant magnetic field become mu 0 I upon 24 pi in the direction of bigger magnitude, inward denoted by cross. For this observation point Q in second quadrature, two perpendicular current, one along x-axis along plus x direction and second along y-axis in plus y direction, form a sort of enclosure around this observation point, and magnetic contribution of these two currents will add together, and they are perpendicular to this xy plane upward, shown by two dots, this dot from x-axis current and this black dot from black colored y direction. This can be verified from right hand rule. When conductor are gripped in right hand with thumb pointing the direction of respective current, this tip of curled finger at observation position clearly indicate brown dot for brown colored x-axis current and black dot for this y directed current indicate vertical upward direction of magnetic field. Now the same magnetic field can also be verified by another format of right hand thumb rule. The finger of right hand are curled along the direction of current in these two conductors. Then this thumb of right hand perpendicular to this plane indicate direction of magnetic field upward as denoted by dot earlier. For this x directed current I, the perpendicular distance of observation position is 4 unit. So its magnetic contribution is mu 0 I upon 2 pi, perpendicular distance 4. And for this y directed I current, the perpendicular distance is 3. So this contribution is mu 0 I upon 2 pi, perpendicular distance 3. Both magnetic field are in the same direction, perpendicular to this plane and outward. So the resultant magnetic field is sum of two component, mu 0 I upon 2 pi 3 and mu 0 I upon 2 pi 4, and when LCM is taken and summation is done, 4 plus 3 becomes 7, and our resultant magnetic field in vertical upward direction dot is 7 by 24 mu 0 I upon pi at this Q point. Similarly, for this third quadrature point minus 3 minus 4 R, the two current won't form a single enclosure, two are in opposite direction for this observation position. So magnetic contribution of these two currents are in opposite direction at this point, and the resultant magnetic field will be the difference of two magnetic field contributed by x directed I current shown by brown line and y directed current of black line at this position. As per Maxwell right hand thumb rule, when x directed current is gripped in right hand with thumb pointing the direction of plus x current, the curl of finger with tip at this observation position denote this brown cross as inward magnetic field perpendicular to this plane by X current, and similarly this Y current magnetic field is indicated by tip of this right hand curled finger at this observation position when thumb is along plus Y direction of current and it is upward denoted by dot for this black colored Y current. So this outward is magnetic field of plus Y direction current and this inward cross is magnetic field of plus X direction current. The perpendicular distance of observation point from X directed current is 4 unit and its magnetic field mu0 I upon 2 pi 4 in vertical downward direction is denoted by this cross, and for this Y direction current the perpendicular distance is 3 unit and magnetic field mu0 I upon 2 pi 3 is in vertical up direction. Since this mu0 I upon 2 pi 3 is bigger magnitude than the other one, so the difference is in bigger magnitude direction upward, and smaller magnitude mu0 I upon 2 pi 4 is subtracted from bigger magnitude mu0 I upon 2 pi 3, and for difference when LCM is taken it is 4 minus 3 1, and the resultant magnetic field in upward direction at R position is mu0 I upon 24 pi Tesla. At this 4 quadrature S point 3 minus 4, when we check the direction of magnetic field for X directed current with thumb in the direction of current, the curl of right hand finger when tip is brought to observation point indicate cross direction of magnetic field, and similarly this Y direction current when thumb is along Y direction, the tip of curled finger at observation position again show a cross. So the two magnetic field of two current of X and Y direction add together in this 4th quadrature, and resultant magnetic field is summation of the two contribution. This can also be justified as around this observation point two current form a enclosure, and that enclosure current curvature is when assigned to right hand curled finger, then the thumb will show perpendicular to this plane inward direction of resultant magnetic field as shown by cross here. The vertical distance of observation point from X directed current is 4 unit, so magnetic field is mu0 I upon 2 pi 4 in cross downward direction, and perpendicular distance of observation point from Y direction current is 3 unit, so magnetic field is mu0 I upon 2 pi 3 again in inward cross direction, and resultant sum of mu0 I upon 2 pi 3 and mu0 I upon 2 pi 4. When mu0 I upon 2 pi is brought as common, 12 is taken as LCM, then 4 and 3 become 7, and our result become 7 by 24 mu0 I upon pi cross vertically inward directed. So in this example, when two perpendicular current bisect at origin and for 2nd and 4th quadrature the two current form a close encirclement, then their two magnetic field will add together. In 2nd quadrature it is vertically upward and in 4th quadrature it is vertically downward, and the summation of two magnetic contribution, one with 3 unit perpendicular distance is mu0 I upon 2 pi 3 and second with 4 unit perpendicular distance from X axis current is mu0 I upon 2 pi 4, and the summation is 7 upon 24 mu0 I upon pi. Whereas in 1st quadrature and 3rd quadrature two current won't form a encirclement, so the two magnetic contribution are in opposite direction, and current with 3 unit perpendicular distance produce more magnetic field, and the difference of two mu0 I upon 24 pi in 1st quadrature is in inward direction and in 3rd quadrature it is outward direction. Now there could be a possibility that two opposite magnetic field at certain positions become equal and opposite and resultant magnetic field becomes 0, and for such conditions this become a straight line passing through origin, and the slope of that depend upon two current magnitudes as explained in our next example. Two straight infinite long conductor are mutually perpendicular and carry current in plus X direction and Y direction as Ix and Iy. They bisect each other at origin. We have to find out locus of geometry where zero magnetic field exists. Now for this current distribution, in 2nd quadrature two current make a single enclosure around this observation position. Similarly in 4th quadrature two current form a enclosure around this observation position. So the magnetic field is additive in 2nd and 4th quadrature, but in 1st quadrature the magnetic field of X axis current is vertically upward, shown by this brown dot, and magnetic field of Y current is vertically inward, shown by black cross. So the resultant magnetic field is the difference of two. Similarly, in third quadrature, two magnetic field of x-axis current inward and y-axis current upward are opposite. So there could be a possibility that two opposite magnetic field become equal in magnitude. For this x-axis current, vertical distance of any xy coordinate observation position is y. So the magnetic field at infinite length and midway position is mu 0 I upon 2 pi vertical distance y, and for y current it is mu 0 Iy upon 2 pi vertical distance x. Now for equality of two magnetic field which are in opposite, for magnetic field neutrality, the requisite equation can be modified with y as Ix upon Iyx. So in first quadrature both x and y are positive, and in third quadrature both x and y are negative, and this is a equation of straight line y is equal to mx plus 0. Solution of magnetic neutral condition becomes y is equal to Ix upon Iyx or y is equal to mx plus 0. This is a straight line passing through origin with slope m as ratio of two currents, and if two current Ix and Iy are equal, then slope become 1 with angle 45 degree, and if Ix is more than Iy, then this slope become more than 1 and angle will become more than 45. If Ix is root 3 times of Iy, then this angle of straight line becomes 60 degree with slope equal to root 3. And if in previous case current of x direction is reverse, then in first and third quadrature, now the two magnetic field become additive, and in second and fourth the two become in opposite direction. This black colored y-axis current is vertically upward, denoted by this black dot, whereas current of this minus x directed red colored ix current is vertically downward, as denoted by this brown cross. And for magnetic neutrality, two magnitude must be equal as they are in opposite in direction, and for Ix current vertical distance is y and magnetic contribution is mu 0 Ix upon 2 pi y, and for Iy current this vertical distance is in negative x direction minus x, and resultant magnetic field is mu 0 Iy upon 2 pi minus x, and solution of this magnetic neutrality results in y is equal to minus Ix upon Iyx. This is a straight line with negative slope passing through origin as shown here, and the slope depend upon ratio of two currents. We hope you will find all these examples very useful in your examination preparation. We assume that a practice of similar nature questions will definitely ensure success in any examination. Our other learning video of the same class 12th physics playlist are equally useful. You can use them in your studies and share them to your friends too. And if you need our online doubt clearing class support and exam centric dedicated notes, do join our YouTube membership by clicking join button just beneath, and a small monetary investment will enhance your exam score capabilities. We wish a very bright future. Have happy learning. Thank you very much.